Okay, so the last video in this chapter is looking at coding. So coding is used when we have some data which are like weird numbers, very difficult numbers, and we're asked to find the mean and variance, etc. Then we're going to use a code to make these numbers a bit more simple or easier to use, okay? And so the code will be, they'll give you the code, so it'll be in the form like y is x minus a over b. A and b are just some values here. And so what we're going to do is use this code to change the more difficult values into easier values for us to deal with, right? Also, things to note is if we have the mean of the coded data y bar, then this is equivalent to x bar minus a over b. So this way we can find the mean of the original data because we can use this relationship here. Same thing for the standard deviation, not the variance, remember standard deviation. So sigma y is actually going to be sigma x over b. In this case, the a value will not affect the standard deviation because a is just like the difference it makes plus or minus, right? So it doesn't really affect how spread out they are from the mean value. Okay, so let's look at this example here. So we have a set of data values x, which is shown below. As you can see, they're difficult-ish numbers, right? So we're going to use a code to make it a bit more simple. So what we have to do is just plug in these values individually into this code here. So 52 minus 3 over 7 and each individual one. So the coded data will now be 7, 10, 4, 10, 5, 11, 2, and 3. So this is the coded data. Now it's a bit more easier to use. They're a bit more simple numbers to use. Right, B, find the mean of the coded data. So we're just finding y bar. It's essentially just the same thing, sum of y over n. So you just add each individual one up, divided by n, 1, 2, 3, 4, 5, 6, 7, 8, and you can get the coded mean, which is 6.5. Use your answer to B to calculate the mean of the original data, right? So we know y bar, and that's equal to x minus 3, or x bar minus 3 over 7. So what we need to do now is just rearrange for x bar because we want the mean of the original data, right? So x bar is going to be 7y times y bar plus 3. So therefore it's going to be 7 times 6.5 plus 3, which will give us 48.5. So from the coded mean, you can actually find the mean of the original data, which is much more simple or simpler than actually having to find the mean of the original data. They haven't actually asked us to find the standard deviation here, but we can also find the standard deviation. So let's find sigma y first, the coded standard deviation. And remember, that's just the square root of the sigma y squared, right? I.e. the square root of the variance of the coded data. So it's going to be square root of, well, the variance is the sum of each individual one. So it's sum of y squared over n minus the mean squared. Okay. So if you do this, you get the sum of 424 over 8 minus the mean, which is 6.5. Remember, we're looking at the coded data and we're squaring that. And so this would be 3.28. So the standard deviation of the coded data is 3.28. If you want to find the standard deviation of the original data, well, sigma y is equal to, remember this, even though the code was y is x minus 3 minus over 7, this 3 does not affect the standard deviation. So it's going to be sigma x over 7. So sigma x is going to be 7 times sigma y. So it's just essentially going to be 7 times 3.28, like this. Okay, so that's how we find the standard deviation of the original data. So as long as you know the relationship between mean of the original data and coded data and standard deviation of coded data and original data, then you can find or make it a bit easier for yourself when dealing with more difficult numbers.